Mesomeric effect. This is a permanent effect and comes into existence in the following cases. A. When an electron withdrawing or electron pumping group in conjugation with a pi bond. B. When an atom or a group having at least one lone pair of the electrons in conjugation with a pi bond. The effect involves the transfer of electrons through pi electrons of the multiple bond. If the system is a conjugated system, means alternate single bond and double bond, that is having an alternate sigma and pi bonds, the effect is transmitted through the whole of the conjugated system and may be termed as conjugative effect. Mesomeric effect causes delocalization, means a shifting of pi electrons, and a number of resonance structures of the molecule are obtained. It can be explained as follows. Let us consider a carbonyl group, that is carbon. Two valencies are satisfied by whatever be the other group. Carbon double bond oxygen. It is an electron withdrawing group. That means oxygen is an electron withdrawing group. Due to the high electronegativity of oxygen, the pi electrons of the carbon-oxygen bond gets displaced. That means carbon-oxygen bond gets displaced and becomes a resonance structure getting carbon positive charge and oxygen negative charge. These two are called resonance structures. Another diagrammatic resonance structure is also possible, where this dark shade shows the density of electron is higher towards oxygen. Thus, carbonyl group may be supposed to be a resonance hybrid of the structure 1 and 2 and may be represented diagrammatically by the structure 3 also. In the structure 3, the electron density is greater at the oxygen as compared to that on the carbon. Now suppose a carbonyl group is linked to a conjugated system as shown. This is the conjugated system with alternative double bond and single bond. Double bond, single bond, double bond. Therefore, this is the carbonyl group. When a carbonyl group is attached to a conjugated system, the displacement of electron from carbon to oxygen can be transmitted further through pi electrons of the conjugated system. That means oxygen is shifted here because of the high electronegativity. This double bond, the pi electrons are shifted to oxygen, making oxygen negative, and as a result carbon is positive. Therefore, the double bond where the pi electrons are there immediately shifted to this position, keeping that positive charge disappears when a double bond comes here. But this carbon atom gets a positive charge because of the removal of the bond from here. Immediately another pi electron will occupy the position and forms a double bond here. Therefore, the total chain, there is a shifting of electron take place and the resonance structure is like this. That means oxygen gets a negative charge because of the shifting of these two electrons. Because of this bond comes here there is a double bond. Now this double bond becomes single bond because as of the shifting of this electron here gets a double bond, and here because of the loss of the two electron, there is a positive charge here, and here there is only one single bond. This is known as electromeric effect.